right.
It better be 37 degrees.
That was good.
If you just said to the right, which I think was what was being said, that's that way, but the vector's pointing this way.
Right.
I plus one.
Now, I would prefer polar, because you can get
Yeah, okay.
any direction with 1 degree notation.
Let's
Or
talk about why that's not always the best case.
any 2-dimensional direction.
Alright, so let's start out with some other vector here. Position, 5 meters I hat plus 4 meters J hat. First, I'm gonna sketch it down just to have a visual. I mean, potentially, you could put this in rectangular form without, or sorry, that is rectangular form. You can put this in polar form without doing, some of you can do it on your calculator, you can picture it in your head, but let's write it down anyway. I'm gonna stick with I hat, J hat, but let's go ahead and write it down again, just as a practice. So I'm going 5 meters to the right and 4 meters up. I and J are perpendicular to each other. Sometimes I'll throw that in there just to reinforce the fact that they are perpendicular. Matter of fact, whenever we're using I, J, and K, they are going to be perpendicular in this class. If you got to senior level or graduate level physics, they're not always perpendicular, but for this course, they are.
I is always X and J is always Y.
No. Which is why I'm using I and J instead of X and Y. When we get into especially inclined plane problems, we're gonna tilt our,
Then K would go to Z.
right. All right, so I'm drawing this down here. My solution, my sum is a vector that looks like that. Here's my X hat. I some angle theta here. This is what we were doing last week. I know that 4 squared plus 5 squared is equal to x squared. So 25, 16. So this is the square root of 41 meters. 6 point something. That angle? Well, I know the tangent of theta is equal to the opposite or the adjacent. So theta is the arctan of 0.8. Which is something.
38.36. May have done that wrong.
It's getting the habit now.
Degrees,
Thank you.
sorry.
So, rectangular form, that is equivalent to square root of 41 meters. I'm gonna bring the line down here, just emphasize the fact that the m is not inside the radical. I see sometimes people do 41 and then I'm not quite sure what they intended there. So, and then 38.66 degrees, polar form.
I hate that.
You hate that?
Yeah, I don't like square roots. Kind of makes me feel like I don't understand what the actual number is.
You prefer decimals?
Yeah, but that's just my preference. I'm just saying.
Well, what's square root of 41?
I have no idea.
Like 6.4,
6.4?
something like that.
I'm starting now.
6.403124.
Say it again?
Keeps going. 6.4031242237.
You don't have to take it that far, but go for it if that's what you want.
Gotcha.
Throw in another twist here. Suppose x x is equal to 5 meters I hat, and let's keep this still, minus 4 meters j hat. What does negative mean?
It means opposite.
It's still 5 meters I hat, so that's going off to the right, and then the negative is opposite. We don't have to define negative j hat direction, we just have to define positive j hat, and negative is just the other way. Now, some students have issues with that. What they would rather have written here is 5 meters I hat plus 4 meters negative j hat. But the problem with that, one, it's not conventional, but two, it looks like we're subtracting j hat from 4 meters. If you really need to write it that way, use parentheses. But traditionally, the negative just comes right out front of that term. So that is it, that negative sign goes with the direction. Even though it's right next to the number or the magnitude, it is representative of the direction. Questions to hear?
The negative makes the whole term.
Say it again?
The negative makes the whole term negative.
Yes, the term. All right, let's do some addition.
This is way better than calculus.
There'll be later on, you'll be thinking, man, I wish we could use calculus for this. All right. We have two vectors here. You can think about this as directions. You start in some place, you're gonna go 5 meters at a 37-degree angle. Now, I will say that we have to define I hat and j hat every time. However, 0 degrees is to the right. That's a convention that we are sticking with unless you define it otherwise, but 0 degrees is gonna be to the right. And then, just like the math people do, counterclockwise are positive angles, clockwise are negative angles. So 37 degrees would be in which quadrant?
First.
For those who have forgotten, 1, 2, 3, 4. This is 90 degrees, so 37 degrees puts us in there. 150 degrees.
Second.
150, this is 180 over here, so 150, something like that. When I add them, we can do it several different ways. So 5 meters, 37 degrees. I'm gonna let that represent 5. And that angle, 37 degrees-ish. So once I'm here, I now have the second set of instructions. What do I do next? Well, I'm now going 7 meters at 150 degrees. 150 degrees is like this. Now proportionally, whatever length is 5, I've set up some scale. This should be proportional. This should be 7/5 longer than that one. Now all I'm doing is a crude sketch here. If we were truly doing this adding graphically, then I would have I'd set up a scale, I'd have a meter stick out here, and I'd be measuring properly. I get the angles down with the protractor, but we're not doing that. We're just getting the crude estimate of what the sum is. This addition right here, this is head to tail. The head to tail method. If any of you have done addition of vectors with the parallelogram method,
I can't remember.
well, that's fine, because I don't like it, so. I was going to address why I didn't like it, but ignore it. Now, my answer, I haven't actually answered the question yet. My sum graphically, I did that one, I now have a new starting point, I did the next one, I now have the final endpoint. The equivalent, if I stopped right there, would be if somebody said, what's 1 plus 2? And you answered, 1 plus 2 equals 1 plus 2. That's all that we've done at this point. A true statement, but doesn't really answer the question. My final resultant, or my resultant, is from where I started to where I ended. If you gave the person one instruction, what to do, this is what's in red right here. This is my resultant. I know this angle right here is 37 degrees. I know that this angle right here is 30 degrees, because that's 150. So math-wise, I have a triangle with length 5, length 7. This angle right here is 67 degrees. I have side, angle, side. That sets up a unique triangle, and I'm trying to find this and the angle. For those of you who have had trig, what would you do?
Side, angle, side.
How would you find the length of the missing side?
Use the equation.
Which equation?
Side, angle, side equation.
Who's had trig in here?
I have.
Okay.
Terrible memory.
I just remember side angle side. I don't remember anything attached to that. I just remember like side angle side,
No.
angle side angle and
There's,
stuff.
there's a bunch of, what is it, trig
Trig
functions?
identity.
I was
Yeah.
gonna say the quadratic formula.
Sorry, Olivia?
The quadratic formula, but.
The quadratic formula only works for right triangles. However,
You could drop another line and create two right triangles.
Oh,
That
yeah.
might be more trouble than it's worth.
well, we're gonna do it that way in just a moment. An alternate way. All right, so this is one of the reasons why, Ray earlier said that he prefers polarization of rectangular. One of the issues is if you're dealing straight with polar, you end up with something like this. The actual way you would solve this is law of cosines.
Oh, yeah.
That if I give it a triangle here with some angle theta at A, B, and C, C squared equals A squared plus B squared minus 2AB times the cosine of that angle. Hopefully bringing back some happy memories for some of you.
Do it
Or
like
future
that
memories
some
for others.
reason.
I took this over the summer, so it was even worse.
If it were a right triangle, if theta were 90 degrees, cosine of 90 degrees is 0, this term would drop out and you're left with the quadratic formula.
Yeah.
Oh, sorry, man, Pythagorean theorem.
Pythagoras.
Pythagorean theorem. Not quadratic formula, we don't need that here,
Thank God.
save it for later.
Dr. Fox, I'm sorry, could you read after the Pythagorean theorem component, after the b squared, could you just read what's there? I can't quite read.
This right here?
Yeah,
Minus 2AB cosine theta.
thank you.
Now, knowing the law of cosines is not required for this course, but for those of you who have done it before, just recognize you do have that tool at your disposal. Once you have that, you would need to find an angle, probably this angle right here, and for that, law of sines. I'm going to go through one of these, just for those of you who wish to use it. It will refresh some memories. After that, I'm going to talk about the way that we typically would do it in this course. So I have c squared, which I'm making this c apparently, equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 67 degrees. So someone will be gracious enough to do it on the calculator and tell me what the value of c is.
How did you get the 67 degrees?
I know that when I set up my new starting point, to draw this vector. I'm drawing my axes parallel to my previous axes. So that, these two lines are parallel. If that's 37 degrees, this is 37 degrees here. And I know this is 30 degrees here. So if that's 37, that's 37. This is 30 because a straight angle is 180 degrees. Right, you're with it?
Yeah.
Okay. And the value of C is?
46.65.
No,
I'm guessing that's C squared.
yeah, 6.83.
Three.
6.83.
Yeah,
Okay, technically meters.
yeah.
Although we haven't expressed our final answer, I don't have to write meters quite yet. To find this angle right here, because again, the angles are based upon 0, where is it relative to 0? I want to find that angle from here to here, but I'm gonna find this one first, this angle down here. This is 6.83. For this, I'd use law of sines. So the sine of 7 over, try that one again. 7 over the sine of my angle down here, which I'll label as phi. With the sine of phi is equal to 6.83 over the sine of 67 degrees. The pattern goes the length of a side over the sine of its opposite angle. That ratio is constant. So 7 over the sine of this angle is equal to 6.83 over the sine of that angle, which is equal to 5 over the sine of that angle, but we don't care about that angle.
Yeah, I can see how y'all got 30, in the, on that part, but then how did that add up to 67?
How do we get 67 degrees?
Yeah.
All right, let me see if I can draw that a little bit clearer here. All right, so I have my original axis, and I have my 5, I'm gonna exaggerate the angle some here, or not, sure. When I set up the new axis, I draw my 7 meters from there. These two are parallel. This dotted line here and my original axis are parallel.
Okay.
Alternate interior angles. And then for this one right here, I know that is 150 degrees because that's the problem. And so this angle here must be 30 degrees. And that's 37 degrees, that's 37 degrees. And so this full angle is just the sum of those two. Other questions up to here? So down here, someone can tell me what the sine of phi is and then tell me what phi is. Sine of phi is more around 0.9.
0.9434. And then 70.63. That would be a degree, right?
Yes.
Okay. I might be doing the math wrong, but you would, once you find the sum of the right side, would you, I thought you would multiply the right side by the arc sine, but, well, I guess that doesn't get you, yeah,
So cross multiply, 7 times this divided by that,
okay,
should get you that number. And
okay,
then you would do arc sine.
gotcha.
I've got, okay,
You got something different?
I think, let me see.
Sorry, say it again?
I said I think, I'm gonna double check, I might be doing it wrong.
Yeah, catching mistakes early, a whole lot better than later. The 252 class, where I made a mistake on that side, where the whole board ended up getting filled. I ended up with an answer that I knew was wrong. And then someone goes, yeah, you made a mistake back there. That's the point when I go, all right, correct that mistake and work it on your own.
Yeah.
I just had a question, is it okay for us to use 6.83 for this, even though that was not an exact number? Or would we want to continue this problem using a longer stretch of numbers?
Personally, I would use a longer stretch of numbers, because that number would already be in my calculator. But, you know, on a quiz or test, it's close enough.
Okay, thank you.
If you were designing something that potentially could kill somebody, if it failed, then yeah, someone's gonna come through and double check those numbers.
So, multiply, you divide the right side, right? And then, divide it by 7, and that equals your, sine of phi, right?
Oh, if, to solve for this, if you divide by 7, then that gives you the reciprocal of sine of phi, because it's still in the bottom.
You should multiply 7 by the sine
Oh,
of
okay.
67 degrees, and then, I multiplied it at first, that's why I got it wrong, but you have to divide it.
Oh, okay.
And then you do the arc sine of the decimal.
Multiply the diagonal, you know, you divide by the number you have left over.
I don't know why I multiplied it, I was just like, it doesn't look like I would multiply, or divide these two.
Now, based upon just a crude sketch here, 70 degrees seems reasonable. It is a crude sketch, so, you know, I imagine I'm gonna be within 20 or 30 degrees. But recognize I have found this angle right here, this angle right here. That's the 70.63 degrees. I need to know the full angle. And so I would add the 37 degrees to it.
107.
And so our final answer is 6.83 meters and 107.63 degrees.
So we usually wouldn't use this method, right?
Right.
Okay. Yeah, I don't-
Oh, boy.
I didn't really.
There are times when if you set up a situation and it just happens to be